Hey, welcome back to the Build It Basement. Today we're going to be working on a Voron Tap, so let's just get into it. Got a new little camera setup here, a little split. I don't want to spend a ton of time kind of doing a bunch of stuff here. I just want to kind of close up and kind of a full complete build. A few people have put these together. I haven't seen any really good videos of the step-by-step, in-depth, close-up. Just make it nice so people can follow. So I got this view right here. Up there, got a little snippet of what we're doing. Here we got a close-up, and up there you got the hello cam. So before we jump into this camera shot though, let's look at the PDF real quick. So Voron Tap, pretty amazing little device. Tons and tons of little screws, very fidgety. Tons of people working on this. Tons. Including Blam. I don't know who Blam is. It's cool. Anyways, so basically what this is a replacement for your Z-stop, and allows you to calibrate your hot end to the nth degree, because your hot end is your stop. So that being said, there is a picture of all the screwy dilly dads and all the plastic pieces that you should have printed or you're going to print to do this. Some heat certs. I will tell you right now, I will go through it, but I've already put my heat certs in, I've already put my magnets in, and I've already modified my board. I will talk all about it and show you the modification. But I didn't want to waste any time showing it because those are things that you can do, because I'm sure you know how to do those things. Tap is, you can read that if you want, that's your own thing. I'm not going to go through this too much. I'm not going to explain what tap is. If you're watching this, you probably already kind of have some idea of that. Tap basically on an MGN 12 rail. It does not go on 9. There are mods out there to get it on 9. You can do that. I will say that the tap is heavier, so I don't know that you'd want to do that, but there you go. Let's see here. How does this thing work? Seriously. So basically there's an optical sensor and there's a little piton, a little button that goes up and breaks the light path on the optical sensor. Not even sure if that's what this says exactly, but that's pretty much what it does. So that being said, this part, this red part that they're showing here, is the part that basically is mounted to your rail, with this black part being the part that will actually move up and down, causing things to do things like that. There you go. Normal, triggered. Triggered, normal. Let's see here. What's this one? This talks about what optical sensors you can use. This is showing you, this diagram is not what you need to build. This is actually what's inside of the optical sensor. Okay, it's not a circuit you need to build. You don't need an amp or an op amp. You don't need a feedback circuit. You don't need the diode. Yeah, they are showing a resistor here, which is a 220 ohm quarter watt resistor to get you your 5 volts. Now, I will say this while I'm going through this, there are boards for 24 and 5 volts as of speaking. Right now on the 18th of January 2023, the 24 volt supply to those boards is not suggested, which is why I'm going to go through the mod that I did, and I will show you that board. They're showing you right here 2 different ways of doing it, one with a PCB, one without. And there's your bomb diggity. Parts, screws, flatheads, button heads, socket heads, certs, washers, nuts, and magnets. One thing about the magnets, they're looking for N52. So basically a pretty strong neodymium or similar. They're saying an N35 will work. Low strength might cause ringing at high acceleration. And the print cut guide is if you are cutting your own rail, because the holes need to also be in a certain place, not just the rail length. And here's where it starts. So let's do this. Boom. Yeah. All right. So where's that picture? That picture is right here. All right. So what we're doing is we have our linear rail. This one's pre-cut. I would suggest you buy a pre-cut unless you want to take some type of cutting mechanism to it. Not only is this cut, but it's also ground down on the edges of it, so it has no sharp edges. Looks like it's machined pretty well, so it's nice, yeah. And I am going to cut this zippy tie that's holding it on there so I don't lose my balls. And it's got a nice slide on there. I have already cleaned this, and I would clean it using the same procedure I used on my rail video with alcohol. You are taking this rail off, so that makes it a little bit easier. So what you want to do pretty much is printed part, and they show it going in sideways, but if you just push it into the end and push your part out, that makes for perfect. Then you wind up with a lightly silicone oiled rail and some lightly oiled ball bearings inside there, because like I said, I've already cleaned it and I've already oiled it. So once you have that like that, that will hold everything where it is, so you don't have to be overly concerned about losing your ball bearings. That's if you're cutting. Most people aren't going to cut, so you can read that if you need to, but it is what it is. This particular page, I'm going to show you that close up. This is removing supports. There are support, unlike most, nay, all the other parts in this printer or in the Voron printers, as far as I know, at least on 2.4, there are no supports and no supports needed. These parts do require some minimal supports, but the supports are built into the STL files. Do not turn support on your print profile when you go to slice this. You do not need that. You just need the ones that are built into STL. So they're showing you in blue on this page what needs to come off. I've already taken mine off. Be careful not to take too much off. And when I say that, I'm specifically talking about this right here. If you see this white piece that stays, blue piece stays, comes off on the back. You are supposed to have these little, we'll call them love handles on the side. Okay, so heat certs, go back to this, heat certs, 1 and 2 right there. That's in the manual. There's also 2 on the back. I think I show those. Yep, they're showing them both front and back on that. So you have 1, 2, 3, 4 on this piece. You have 1, 2 on that piece. And you have 1, 2 on your accent piece that has the piton, the button that goes up into your optical sensor. These ones are a little different. They're recessed in well below the face of your plastic. But there is kind of a little stop point in there that you can see when you put them in. So try to get those to the right depth. Those ones are a little bit tricky. So yeah, so that and that. And oh, and last but not least, heat certs into your magnet holders. Okay. There you go on that. One last thing on this. So on this piece right here, you do have your little tiny nut that's on there as well. And the magnet holders. So on the magnet holders, these guys right here, there is a right and a left. One has 2 dots on it, one has 1 dot on it. I forget which is which right now, but I can only get them in one way, but you may be able to get them in both ways. So this one has the multiple dots, so this one has the single dot. These are relatively hard to push in. They are meant to be that way, but the Voron team would also like for you to use a dab of either super glue or RTV silicone, or I don't know, I would just use super glue. If you don't have super glue, then you crazy. The way I put these in, just to be clear, basically is I put my magnet on my pair of pliers, stuck it on there. I put my super glue on the inside of it, and I gave it a squeeze, and I squeezed it down, locked in place. Your magnet should be flush with the top of your plastic when you do that, and you can do that twice on 1 and 2. Okay. Polarity does not matter, but it does matter for neatness. So These are opposing. They do not want to go together, although they will chase each other and spin each other around. So that's kind of cool, right? So their polarity does not matter. So if you mess it up, don't worry about it. Even though those take 2.5 minutes to print, give or take. Let's see here. All right, let's start with assembly. Before we get into that, I'm going to bring this full screen. So we're going to use some M3x20s, some M3x16s, and I'm going to grab my measuring device so I make sure I use the right screws. So the M3x20s are the first screws that go in. There's 2 of them. They basically connect the primary body to the secondary piece because it wouldn't have been printable otherwise. And then there's a secondary set of screws, the other ones that we're going to do with the M3x16s that also hold that in, but they also serve the function of holding your tool head onto this as well. So we need our M3x20s, these 2 guys right here, and we need the piece that we have in our hands right there, and we need to basically set this the way we need it. So I'm going to set it with the divoted side facing towards me, and that is going to basically be going on like this. So you kind of have a keyed area there. It feels really insecure until you get it screwed together, but the screws will hold it together pretty well. So I'm going to start these screws. My holes are, no, I guess they're not too tight. And I'm going to set that in like that. And I'm going to grab a tool. Spend a little time when you're putting the heat certs into these parts. Most of them are pretty thin. And most of this is pretty, or is it relatively precise? So make sure your heat certs are in straight and true. And we're going to tighten that up till you're tight. You know what I didn't do? I didn't put any thread locker on that. Pull that one back out real quick. And here's a little quick tip. Actually, I can't do it on this. Nope, I can't see it. A little quick tip. If you can see the back side of a heat cert that you put in, you have a screw that's going through into it. One thing you can do is, if you forgot to put thread locker on your screw, is to actually put your thread locker in from the back side. It's a black diamond or a pro tip or whatever. Or I've messed up so many times, I figured out ways to make it better tip. You pick. All right, so we'll get that one in. I'm not gonna get all the way tight. We'll tighten them up when we both have them both in. Loosen this one back up. Get a little thread locker on that. I really do like this lipstick style, chapstick style, whatever you want to call it, thread locker, especially for larger screws. Not that these are huge or anything, but a little bit neater. I don't plan on taking this back apart anytime soon, so I want it to hold, baby, hold. All right, tighten that up. And I'm not trying overly hard there. I'm going slow just because I'm trying to feel it. All right, and then we need our M3x16s. That would be these guys. Just confirm that real quick. Oh yeah. And these are going to go right into these holes above and a little bit inside to the first two that we did. And these right here are gonna be left out about, was it 2.5 millimeters? And to speed things along, we'll get this out. It's gonna be pretty close. Caliper out real quick. And it's one of those things that doesn't have to be dead on. That's a little much. That was about 3 1/4. Give them a couple, like 1.5 full rotations. It's kind of hard to measure this. .72, 2.52. I can give this one just a slight little tweak. There we go. Should be good enough. All right. So, looking back at that thing right now, where are we at? We're here. Now we're putting our optical sensor in. Okay, so we're gonna flip this upside down. And before we actually start that, I'm going to talk a little bit about the optical sensor. So these boards are designed and come as either a 5-volt unit or a 24/5 volt unit. So this one happens to be a 24 and 5 volt unit. However, it has been found that there are at times voltage spikes that can come across that 24 volt that go over the limit that the IC on this can handle. Okay, so when that happens, you let the unghostly, ungaudy smoke out of the IC, which means that no working no more. So you can still hook up 24 volts if you like. It's suggested that you put a what is it, a 2.2 ohm resistor in line, just to kind of cut back on that voltage coming through. At the very least, if you want to hook it up straight up 24 volts, feel free. You'll probably rip it apart to fix it at some point. It happens mostly on power up, and that's all I got to say about that. But modification on this one, I've gone ahead and removed the components on the section that is adjacent to the wiring harness that's on here. So if I recall correctly, there was the IC, a capacitor, a resistor, another capacitor, and I think one other thing. And that was done using a chisel tip soldering iron that was heated up pretty high and just pushing them right off. So basically, here we go. Basically heat up your soldering tip pretty high and just basically wiping them right off the board. You do that, they'll come right off. Like I said, you want to get that soldering iron pretty hot. Give it a second on there and push, second on, push. The only thing you're going to have to do at that point after you're done is to jump the 3 solder points where your IC was on the top side. Basically, if you're looking at this connector up here, the best way to do that I found, you can try to do it with solder and you might have some luck. What I wound up doing, because I just don't like jumping solder for one, but I found it a little difficult to do, is I took a piece of wire like this, I took out the strands, I put 3 or 4, spun them around like this, so you get a tiny wire, probably something in the range of like a, I don't know, 30 gauge-ish, doesn't matter. And then I stuck that back in. I'm not gonna do this whole thing, but basically I used the plastic on the wire as kind of a heat shield for my fingers, because copper will get hot really quickly, well before you melt the solder. And basically I soldered across using the wire like so, okay? Once it was all soldered on, I came back in with my flush cuts and I flush cut the end of it. so everything's nice and neat. So I know I got all 3. I've tested this board. To test it, if you want to test it, basically you're going to need a 5-volt supply. USB supplies are 5 volts, or if you've got a bench power supply, I don't have mine out anymore, but if I did, your red wire is going to be 5 volts, okay? At least on this board. Check with your board. Your blue wire is your ground, so that's a big one. Blue ground, red power, and your black wire is your signal. So once you hook power and you hook a ground to that, if you use a multimeter, and you really don't even need to, but if you hook up a multimeter, you can basically see your closure on this optical switch when you pass something through in between there. Okay, once you get that done, you're ready. Now let's put it in. Oh, one other tip here. So when I was first trying to fit everything together to make sure I didn't draw this video out too far, I noticed that the soldering points for the connector on the board here were causing me to hit right here in the middle. So I went ahead, and I'm not sure if it's going to pick up on camera very well, but I put a tiny little notch right here, and I just did that by cutting, little notch. Now my solder points aren't hitting, so everything stays flush. Okay, and this is going to use some M3x8s. Grab a couple of those, and these are directly in the plastic, so they're not really doing much other than holding this little tiny PCB on. I will also say, when you're putting this on, I wouldn't tighten it all the way, because there is a little bit of play with this, and your ABS print with the button on top is going to fit into the optical switch, and you want to make sure that you're in the center of the optical switch. If you're not, it will cause some drag, and you don't want any drag with this. You want this to run pretty smoothly. Okay, all right, so that's what we have there. Let's go full screen on the PDF for a few points for neatness. Totally agree. You got a PCB board, you're the neatest guy around. Now you could solder directly onto this board and get rid of that connector if you want to. That's up to you. So the next part they want us to do is they want us to put in 2 little flathead screws on this, and I actually have already installed mine, and they're hard to come out, and I don't want to take them off. I don't have to. So that would be this screw and this screw. Okay, these screws are actually where the magnets are going to get attracted to. They are going to be flush, or pretty flush, when you have them installed properly. They will also be pretty tight, so don't over tighten them to break everything, to rip out your threads, but you want them as flush as possible so these nice and flat, so everything will function properly. Let's see here. The other thing we're going to do is put 2 of these little M3x6 button head screws on the back side, and the only function that those serve is your tool head is going to rest on these when it is inserted on this. So yeah, done. Skipping all the fun facts. So now we're back over to here, and we need to insert our magnets. Okay, so I don't recall which one's which, but I will tell you that your heat certs face in, not out, even though your screws are going in. So your screws are actually going to pass through the base of these into your heat certs. So keep that in mind. So heat cert here facing this way, like that. Okay, and then these are screwed in with some M3 by 10. M3 by 10? Oh, there it is. M3 by 10 button head screw. Yeah, and you may, if you seated these all the way down, you may have to pull them up a little bit. They may fall too deep. So you may have to work them out a little bit. And you don't want these tight. For right now, you just want to grab and then loosen it up so the screw's held, but these are gonna move freely, okay? It comes in later with a little bit of fine tuning on where those are actually gonna wind up at the end. Pull this one back up a little bit. Again, I'm just going to make sure I catch, then release. Okay. There we go. Good. All right, so those are in there. That's what that looks like when it's done. Screw with washer, screw with washer. Loose. Do not over tighten. All right, so next up we have attaching our rail, which is, it might seem odd that we removed our rail from the carriage or the carriage from the rail, but the reason for that is we need to get to the screw holes. This rail is so short that without that, there's no way to attach it. So I'm going to face this upwards so that that stopper, that light stop, is going to be facing up. Rail's going to go on like that. First screw to go on there is going to be an M3x6. Okay, M3x6 would be this guy. So the M3x6 is getting screwed through the rail, through the plastic, and into the nut that's on the back side of this. That one's going into a nut, okay? Your next one is going to be an M3x8. And that one is going into a heat cert that we put in, or heat insert. I keep calling them heat certs. I call them heat certs. A lot easier. And then, by the way, those aren't tight. The last one to go in is going to be an M3x12, also a socket head screw. But that one's going to get a heat cert on it as a spacer. Now, there is a top and bottom to these, and you're actually going to face what would be the bottom towards the screw. The bottom is the smooth part that normally goes into the plastic first, and that is the part that's going to go into our screw first. So we have a wider area facing down into that rail. Tighten that up on there. And the reason for the spacer on that piece is because your carriage is actually going to use that as a stop. So this is your stop point, okay? And I forgot to put some thread locker on these. These ones I can see from the back, so I'm going to use that tip I gave a second ago. Where is my thread locker? Oh, there she goes. So this is what I was kind of alluding to, is on the back side. It's a little bit of thread locker in the hole, a little thread locker in the hole. And then some of it will, long screwdriver, some of it will get pushed out, but there'll be enough in there to hold. And then this one, that, and then we might as well get that nut too. These ones you want to be pretty firm with. You don't want them slacking around or nothing. So there's where we're at. So we got a rail on, our buttons on top, 2 screws, 3, 6, and then our 12, 6, 3x6, 3x8, 3x12, magnets on the side. These are loose, buttons on the top. That's what we wind up with. Okay. Next up, It's a Hall effect magnet, Hall effect switch if you're using that, or if you're using an X-axis switch for like a Trident that goes on the tool head, you can do that. You can do it with a Voron 2.4 if you wanted to. But we already got our switch pod on there. Decided to go with that. We could also do homing using software if we wanted to, but I decided against that. All right, so next up is actually attaching this thing to the printer. So I'm going to stop for a moment. Give me a second. All right, so installing onto our Voron. So I've gone and I've lugged it back up onto the bench, and we're just gonna look at this belt routing real quick. At this point, we do have our AB belts on here. They're telling us to basically loosen everything up. Everything is still loose on my printer. And if you watch the previous video, my belts are being held on by a couple of zip ties currently. So this will be the point where we're starting to tighten things up a little bit. So the belts are going to go through the center, meaning on the center of the back of the unit, and then they're going to come out through and then kind of back in through like a shoelace. So let's do that real quick. I think this will show you what I got for a setup with belts. There's our belts right here, our A and our B belts through here. A little long, we wanted them long, we left them long. I'll switch over to this camera. Yep, it's very, very close, but should work, right? So I'm gonna cut these off. These are just kind of holding the belts for us until we got around to doing something with them. Okay. And basically what we want to do is bring our belt through the back side. Make sure I get this on camera. Through the back side. Top. Back side bottom. So these are going straight like that. Then I'm going to grab my other side. I'm going to do the same thing. Pull them. Keep them kind of similar on both sides. Remember, we cut these so the quantity of teeth on each belt is the exact same. So we should be able to pull them to the exact same length on both sides when that time comes. And then the next step, and I'm going to hold off on this. If you look at the PDF, they now want us to tuck that through. I'm going to get this attached first before we pull that through. I think that'll make things a little bit easier for us. And then we'll get the, and then we'll get to where we need to be. So let's get these relatively tight first. I'm just looking at my belt, see if they're the same length. That side. And then same length, pull in the center. So this side, I need to tighten up a little bit more. And getting these equally tight for your A and your B on both sides tremendously helps with racking. So if they are equal, everything should work out. So they're pretty tight right now, but this is one tooth too far. So I just pulled it back by one tooth. I'm just going to meet them at the center here. The same, and have a decent amount of tension on these. Okay, so now what I'm going to do is I'm going to take these belts, I'm going to pass them back through these side holes. so the other one now. These are meant to be tight, by the way. This is pretty much our method to hold these on. I like this. I like this a lot better than the original. This is a much better setup for belts. And that last one, boom. All right. Here we go. Ooh, that sounds good. All right, so that is there like that. We've got our belts through. We've got a piece position. It's centered. Our belts are not by any means tight, but they're not loose either. You could probably run the printer like this at slow speed, maybe at normal speed, but we have our tensioners to get more on that. So let's get back to that PDF, take a look at what we're supposed to do next. Make sure adjustment screws, yeah, so everything was loose, including our tensioners on our front. So now they want us to put our carriage back onto the rail, which is kind of scary. So let's do this camera for this. We're going to use the retainer that we had, and I'm going to hold it up against it, and I'm just going to let the rail slide from this and onto the real rail. And back to the PDF. Now we're going to attach. So at this point we're going to attach our front panel plate to the rear. We haven't even attached that to the... When did they tell us? They did not tell us. Interesting. So it looks like they... Yeah, let's see. Secure the X-axis MGN 12 using 4 M3x6 button head screws. Okay, so they're telling us to use 4 M3x6 button head screws, retention of belt and adjustment screws on the front idlers. Okay, they tell us, but they don't show us, but they show attached here, so we got to do that first. Let's go to this. Let's see, M3x6. I must have some M3x6s here. M3x6. Oh, I know what these are. Let's see. M3x10s. M3x6. Yep. So 4 M3x6s. And I'm going to lightly get those in. You should be good for the moment. Let's see if I get a little thread locker in that rail. Don't know how I'm going to get in the bottom, so we'll get those top screws in, then I'll use a little bit of the paste on the other two screws. So let's back this up a little bit. Just gonna start these. I'm not gonna tighten them down very far. I'm gonna take these two guys. A smidgen of red lacquer on those. Actually, we should have done it before we put the rail on. Okay, rail's coming back off. I mean the carriage. Carriage back off. Screw back in. Sorry about that, folks. And I'm going to tighten them down. I'm going to do a crisscross pattern. Okay. Not too shabby. All right. Now back to the scary part that we already did once, so shouldn't be as scary to do it the second time, right? There we go. So when you're signing up, I don't know if I mentioned it before, but you definitely want to use a light oil on this. You could probably get away with a little bit of lithium grease. I probably would not use a Mobilux grease on that. I am just using silicone oil because right there, that movement, that's all it's ever going to move unless bad things are really happening. All right, so now back to the PDF again. We did that, we're doing this. All right, and back to close-up cam. So screws are still exposed on the back for this, so we can tighten this up once we have exactly what we want. This has a little bit of play movement in it. And basically going to set that over and push that in. Like that. Getting the right movement out of it already. All right, let's get a little bit of thread locker on these guys. So we pretty much got opposing rails here. We got the rail we're attached to right now, which is running perpendicular to the actual X rail. To give us that fun fidget motion. I will say, if you have fidgety fingers, there's a lot of little screws with this. Okay. And this one in. And last but not least, finger tight that one. Do a crisscross motion here again. We don't want to over tighten these too much. But we do want them secure. All right, now the manual's making a funny, telling me if I have excess belts, I can tuck them. Yes, I have excess belts on purpose. But before we do that, we're going to flip this camera back to the back side, which you're not seeing right now because you're looking at the manual. which is what I mean to do. And then boom, look at that, backside. So backside, making it easier for me to work. Our optical sensor is still moving, so I'm gonna put it down to where it's going to be, so where it's seated. I'm gonna grab the right driver, and I'm going to tighten this down now. In the long run, we do not want this shaking around, coming up with false positives. Give it a jiggle every once in a while, make sure it's still floating, which it is. Not too shabby. All right. And we'll go here. And we'll tuck these belts. We're also going to cut back the excessive belts that we have here. So I have excessive belts. Like that. Pull the other one through as well. Yeah, this is a much better setup for the belts. If for nothing else, this is better for the belts. I'm going to be completely blocking the view of the camera here, so let's get back over to this one. There really wasn't much room previously for extra belt. Pretty much just had to jam it in. This is pretty dang well thought out. Kudos to the team. Progress is good. Boom. All right. And everything is still the same length. I have a good way I could quickly measure. I'm going to wrap and count the teeth from the edge. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 22. Yep. There we go. All right, so that's way too much. We know we don't need that much. I almost lost a toe. So I'm gonna just cut these back a little bit. There. Don't forget these washers. We didn't. All right. Awesome. Cool. All that jazz. So, don't really have a camera hooked up right here to do a final kind of an outro type thing. So I'm gonna use this guy on the tripod that we're using for the thing printer a minute ago. That is the tap. That is the tap installed on the Voron 2.4R2. And our next step is going to be putting together our stealth burner in our Clockwork 2, which is again going to be a lot of fidgety work, but really important stuff. So if you like this video, hit that like button. If you're interested in seeing these types of videos, hit that subscribe button. I'll see you next time, hopefully, and we'll continue this build. See you later.